guys, Easy Ali here once again, and today we are gonna be continuing about the last video, which was about voltage reducers or voltage dividers. And so one of the particular problems that we faced in the last video was the resistor mismatch. And so in this video I'm gonna be talking about first what is resistor mismatch, what do I mean by resistor mismatch, and then I'm gonna show you guys in particular a simulation results which is done in MATLAB Simulink, and then I'm gonna provide a suggestion how we can get rid of resistor mismatch in the circuit, and to do so I'm gonna talk about operational amplifier circuits. Now guys, please be notified that the purpose of this video is not to teach you guys how to simulate the circuit, but rather show you guys how things work together as a whole. So if you really want to learn about the simulation that I will be showing you guys, please do let me know in the comment, and I will try to make one video about the simulation and how you can do it. So with that in mind, let's get started. Okay guys, so in the last video we created this voltage divider circuit to convert the 10 volt signal, for example, to 5 volt. Now you can take any output which you want depending on your design, but in this case we made it 5 volt. And now I'm connecting my 5 volt signal to digital converter of the microcontroller system. Now the reason I'm bringing up microcontroller in general is that, for example, there are cases where you want to measure a signal which is rated for 20 volt, which is 20 volt, but your microcontroller is only rated for 5 volt, so you cannot really directly connect it to your microcontroller, and then you would like to take advantage of this voltage divider circuit to be able to measure it. But then you will design your system, and then you will be a bit unsatisfied with the outcome results, and you will see that you are really not getting this 5 volt output. And so really, and the main reason is that if you go through the ADC blocks of microcontroller, usually the inputs, they're being protected by resistor to avoid flow of current within the microcontroller circuit. So, and if I, for example, in this case, I have made this resistor connected to ground, and I have made the value 5 kilo ohm, right? So now, if I go back and run the simulation, I will see that I'm no longer getting the 5 volt output, and rather getting a around 3.3 volt signal. And so let's see why is that. Let's see what's the problem with this circuit now. So now if I look at my overall circuit diagram, I'll see that I'll have a 10 volt circuit, 10 volts power supply or signal, and that this goes through my voltage divider. I'm gonna denote it as VD, and then I'm taking the output from between these two resistors here, and then I'm taking it and I'm connecting it where I call this a microcontroller, even though it's not really a microcontroller. I'm just showing you guys. So you will see that the circuit is no longer the same, right? Instead of just having two resistors in series, now I have another resistors connected with R2 in parallel. So really the equation I showed you guys in the last video no longer stands and no longer holds true, and so you cannot really use that equation anymore to get 5 volt signal here. So let's see what can we do about this problem. This problem is called resistor mismatch. So you have an extra resistance here which you don't really want. So let's see what we can do to get rid of this problem. To get rid of the problem, you can introduce another circuitry which is called operational amplifier. So for example, now if I connect the output of my voltage divider to operational amplifier, and then take the output from operational amplifier to my microcontroller, then this should solve all the problems with resistor mismatch. This is really simple circuitry, but yet very useful when it comes to resistor mismatch. So for example, if I run the simulation now, I'll see that I'm getting 5 volt signal, which is perfect. So all you have to do is to connect the output of your voltage divider to a positive input of the operational amplifier, and then connect the output from operational amplifier to any system that you want. However, make sure that you have to feed back the output of operational amplifier to the negative side of the operational amplifier. So usually if you go to the datasheet of these operational amplifiers, you will see that they have like 5 pins. Two of them are these 2 inputs, and one of them is for outputs, and there are 2 pins where you have to supply them with certain amount of voltage. So really, all you need to do is to put this operational amplifier in between the 2 of your system, and then this will automatically fix any problems that you would have in terms of resistance mismatch. Just to show you guys, for example, if I go and change this value to another value, let's say 2 kilo ohm, if I run the simulation again, I will see that I'm still getting the 5 volt, which is what I designed in my voltage divider circuit here, where I made R1 equal to 5 kilo ohm and R2 equal to 5 kilo ohm. Okay guys, to summarize, all you have to do is to first design the required output voltage based on the following equation, which is input voltage multiplied by resistor R2 here over the addition of R1 plus R2. Then you have to check whether the system you're connecting your system to already has operational amplifier or not. There are some microcontrollers which come there are some microcontrollers or systems that already provide that operational amplifier input, so you don't really have to connect it. But if it doesn't have, then you have to connect the operational amplifier to the output voltage here, and then finally you have to connect the output of operational amplifier to your desired system, and hopefully this will fix all the problems, and your design will work perfectly, and you will have your desired voltage that you want. Thanks everyone for watching the video. If you found it helpful, please don't forget to subscribe, like and share.